talk about the work we do at Southampton in the World Pop group. There's about 30 of us in that group, mostly focused on research and supporting different governments on population mapping in various ways. And okay, so I'm unfortunately going to start with bad news. If you read the newspapers nowadays, there's the threat of Russia invading Ukraine. We've got the COVID pandemic. We've got our Prime Minister ignoring all the rules at that time. We've got climate change. We can't even eat bacon anymore, giving us cancer. Oh, and my beloved football team lost 7-0. Maybe that's more of a personal bad news. But if we take a look at the world in general, things are actually getting better. Along the x-axis here is income per person. The y-axis is life expectancy, and each of these dots is a country of the world. And you'll see across the century, all the dots are moving up to the top right there. There are occasional drops as there are famines, conflict, but it's generally a good news story. People are living longer, healthier lives, and getting richer. That's the case if we measure things at a national scale, but when we start to dig into data and think about looking subnationally, we can get quite a different picture. So here we see the under 5 child mortality rate, broken down by region of country, with the worst performing region in blue and the best performing region in red. And we see big variations here. So if we just look at the average for a country, we miss a lot of information and a lot of what's going on. And we look at a country like Nigeria, where the best performing region is doing not too bad on child mortality, but the worst performing region is some of the worst in the world. And again, if we map things out and we look at the female literacy rate, another kind of metric of development, Nigeria here, about half the women literate, some big progress overall over recent years. If we start to map that out though, we see that one region there is greater than 80%, but in the north we have less than 30% of female literacy rate. But that's still, each one of those regions is still bigger than the whole of the UK, bigger than some big European countries. What we'd ideally like is something like this that really picks out what is going on in the country, so that resources, so that efforts can be targeted to specific locations. And there have been big moves politically to try and get to that point. So this is the Sustainable Development Goals that were initiated back in 2015 with an idea of improving life for everybody up until 2030. And all the countries of the world signed up. We had all the big celebrities of the time, Obama, the Pope, DiCaprio here, and some B-listers. We have Shakira and Jamie Oliver doing their thing. But there was, this is made up of 17 goals, 169 targets that all the countries of the world signed up to in terms of reducing poverty, reducing hunger, and you can go on and on with that. And a big feature of all of these was leaving no one behind. Of course, that means this word comes up in many of the indicators and targets everywhere. So geography starts to become important. We're trying to achieve all of these goals everywhere. So we're not leaving people behind. We're not measuring the progress of a country just by the average or the biggest city. And that's shown in the very first goal, 1.1, by 2030, eradicate extreme poverty for all people everywhere, currently measured as people living on less than $1.25 a day. So that means we firstly need good maps of everywhere. We need to know where everywhere is. We need good maps of where and how many people there are everywhere, if we're eradicating poverty for all people. And of course, we need good maps of the level of poverty everywhere. and we need to be able to track these over time if we're going to be able to tell that a country is making progress towards that goal and has achieved it. Of course, nowadays we take for granted, we get out our smartphones, we look on Google Maps, and I've chosen Romsey, of course, here, and we see every single building mapped out, often named. I can see Goodies Fish and Chips, Cake Girl, all these places I haven't been to, but something we take for granted. And this is quite a small town, Romsey. If we go to a town, Lubumbashi, in the Democratic Republic of Congo, this is about the size of Birmingham, 3.5 million people. All we have is some roads and a gas station. Not ideal if we want to be able to map and monitor these goals. We can go outside of Romsey into the countryside. Here's Mottisfont, still every single building mapped. We go a similar distance outside of Lubumbashi. There's nothing. We know there's a village here, but they just don't appear on any maps. That doesn't mean they're not mapped, but often the kind of maps that we're having to use are things like this, of you can find this village by turning right at the nearest cow. So it's not ideal for being able to monitor and measure progress towards these goals. How about population? So moving on from just the basic maps of where everything is to maps of where the people are. In the UK, we have our census every 10 years. So now 2011 to 2021, and in between we have pretty strong registry administrative systems that can map changes in population. So we see really detailed maps of where people are. Democratic Republic of Congo, again, this is a country about the size of Western Europe. And we do have population data. You can see on the right there, we have maps of where there's high population and low population. One problem is that each one of those units is about the size of a European country, the size of Austria or Greece. But the major problem is the last census was in 1984. So really we have pretty limited idea of how many people there are and where they are. And then the maps of poverty. In the UK, again, we're blessed with fantastic data. This is the index of multiple deprivation that's updated every year, very fine scales, gives an idea of rates of poverty. Equivalent map in DR Congo, there's nothing. So what can we do? There are opportunities coming along from new types of data. So this, we all have a GPS now in our phones, and what is often done in many countries to replace the kind of administrative and registry data sources that we take for granted in the UK is household surveys, and those are more and more being mapped to where those questions are asked. So it starts to give us an idea of the patterns and distribution of, in this case, the female literacy rate. Another source of data is satellite imagery. When I was doing my PhD back in 1998 now, I think, this was the kind of imagery we were using, where you could just about see the land and the sea. But over time, those images have improved drastically. So we can now see individual buildings, people, cows, and sometimes videos from space. And of course, computing power has increased, and so has the sophistication of algorithms. So with our eyes, we can immediately see in this area of Afghanistan here where the residential compounds are, and we could probably take a pen and draw around them and map them out. But it would take us maybe a year to do the entire of Afghanistan with the millions of compounds. But nowadays we have computer vision, deep learning, machine learning that can recognize what a compound looks like, and in a fraction of a second be able to pick out where those buildings are. So we start to be able to get towards that situation of having good maps everywhere and fill in those gaps that exist in places like DR Congo. And this is being done with greater and greater accuracy all over the world. So we're now working with data sets of all the buildings in DR Congo mapped from satellite imagery in an automated fashion. And it's not just satellite images as if we were looking down on the Earth, but there are other things that can be mapped. So this is a map of the Earth at night. We see interesting patterns like this, South Korea lit up, and I think just Kim Jong-un's house and the dot in the north. We have amount of vegetation, we have topography, we have land use, and of course mapping of those human settlements. It becomes pretty important for knowing where people are and where they're not. Another form of data comes from mobile phones. If you had a phone about 30 years ago, a mobile phone, this is probably what you might look like, and you probably have very few other people to call. But over time, even in the lowest income regions of the world, the number of mobile subscriptions per 100 people has approached 100 and sometimes gone over 100. There are actually now more mobile phones than people on the planet. And why this is a useful data source. If I was to make a call or receive a text message at 9:48, that would be routed through the nearest tower, and that kind of digital breadcrumb of me making that communication gets recorded for billing purposes. If I moved then to a different place, made a call at 10:48 or received a text message, again, that's routed through the nearest tower. And it means I'm dropping these kind of anonymous digital breadcrumbs of mobility. And when you aggregate these across the millions of customers that some of these mobile companies have, you get not only beautiful artwork like this, but this is the movement patterns of millions of people across Bangladesh over the course of 3 months. And I'll show later on how this can be useful. And it's not just kind of calling and text messages. Now, some of the big tech companies have been making use of the kind of app data that they have. So the movement of Android devices, whenever you're using the Wi-Fi, it's routed through your GPS location is recorded, and it gives indications of mobility patterns like this across the entire world. So in Southampton, our group tends to try and construct giant data sandwiches like this. They tend more to look like this. We're trying to bring together all of these different types of data. So from the more traditional sources of a census matched to the boundaries where the population data was collected, to that GPS located survey data, to locations of villages, health facilities, road networks, the mapping of buildings from satellite imagery, and those mobile phone movement patterns, aggregated and anonymized, importantly. Quite sensitive data, obviously. I'm sure we'll talk about that later. So the question of, firstly, how can we actually use this monster data sandwich to try and tackle some of the questions I showed at the start? Firstly, if we think about getting more detailed population maps, often what's publicly available or what is stored in some countries is this kind of data where you're producing a population map, but each one of these administrative units has about 100,000 people in it. And we don't really know where those people are, which is not ideal if we're trying to position a health facility or some poverty alleviation intervention. But what we do have, of course, is all of that stack of data in the monster data sandwich. So we have the mapping of building footprints that tells us, actually, there's probably nobody in those places where there's no buildings. We have things like land cover that can tell us that there may be higher population densities in one area than another. We have these satellite images of the Earth at night that can show us higher areas of higher electrification and probably therefore higher population densities. And so what we do at Southampton is build machine learning models to look at the relationship between the densities from these kinds of data and then translate them, downscale them to disaggregate to this kind of scale. So we go from broad to 100-meter grid square estimates of population distribution. And this is something through the kind of computing power that we have now available we've done across the entire world. and for multiple time points from 2000 to 2020. And it looks like this. And of course, being able to do this on multiple time periods, you start to see some of the huge changes that have taken place, particularly in places like China from 1990 here to 2010, showing the massive urbanization and movement of populations that have taken place. So that is great, but as I showed at the start, there's a kind of basic data problem in these countries. What I've shown there is taking census data and disaggregating it to these grid squares. The problem is, in a country like DR Congo, where the last census was 1984, we don't really have good estimates to disaggregate. We're taking old data and producing bad outputs. So how can we actually estimate the population numbers? And it's not just the DR Congo with its census in 1984 that has problems. There are many countries that haven't had a census for decades. And there are censuses that have been done that miss populations, that produce pretty inaccurate results. Even in the countries that do regular censuses, there are lots of changes that occur in between those in that 10-year period. And recently, COVID has meant that many countries that planned to do a census in 2020 or 2021 couldn't do it. They couldn't go door to door. And so there's been no data collection. And of course, these kind of changes have been occurring. This is changes and the growth of settlements just across a 10-year period in Vietnam. Huge changes have occurred that are hard to forecast. What we were faced with is one example in Afghanistan, where the last census was 1979. And the estimates that are used are largely based on taking that 1979 number and assuming a straight line projection of 2% growth each year. Unsurprisingly, that produces massive uncertainties and very inaccurate data, particularly at subnational scales. 1/3 of the country had been covered by what we call a rolling census, where they have been able to estimate population numbers. And this is what the data collection looked like from around 2015, 2016, but still big gaps in those areas that were Taliban controlled at the time. Obviously now we have a very different situation. What we do have, of course, across the whole country is this stack of data that cover the whole country and can potentially help us fill in some of those gaps, including the mapping of all the residential compounds that I showed earlier. So what we're doing is trying to leverage this giant data sandwich to look at statistically what are the relationships between population density where we do have data and some of the things we can measure across the whole country. So the density of residential compounds, the amount of vegetation measured from satellites, how fragmented settlements are. And each of those produces some kind of relationship, and it's often a very messy one. And we have to try and measure the uncertainty, but bringing that stack together gives us quite a powerful way to be able to measure and estimate populations. And it does a pretty good job. We can leave out some districts. We can use those geospatial data sets, monster data sandwich, to predict what the population should be, and then compare it back to what was measured. And this gives us some confidence to be able to fill in those gaps and produce estimates for the first time since 1979 census. Importantly, we're measuring the uncertainty as well, because some areas we haven't got much data and we are making big predictions in. But that gives us a way to produce those population estimates in that situation where there hasn't been data collection. So that gives us a way to get to the basic maps, to get to population maps. How do we get to those poverty maps for that goal 1.1? So here is a quick quiz for the evening. This is Sao Paulo. I wonder if you can pick out the rich area and the poor area. That may be quite easy, but how rich is the rich area? How poor is the poor area? And how is that changing over time? That's the challenge we have if we want to map out and monitor those changes in poverty. And so this is a similar situation in Dhaka in Bangladesh, where we have a rich area on one side of the river and a relatively poor area on the other side. And what we do have is field teams that often go out, take a sample from one area of a city, ask questions about income, consumption, poverty metrics, and do the same in other parts of the city. And what this looks like across an entire country is something like this, where they've taken the GPS location of the places where they asked the questions. And of course, it gives us information on the rates of poverty just in a small sample of areas, but it does help us then in a similar way to the Afghanistan example. We do have this geospatial stack across the whole country that does cover the whole country, and we can start to look at relationships in the places where we do have data to see, in this case, looking at the distance from major roads. So we tend to see high rates of poverty further away from major roads. We tend to see lower rates of poverty in urban areas. We can also make use of some of the mobile phone data. So what we see here is something called the radius of gyration. It's not a kind of dance move, it's a measure of how much people move. And what we see is it's often that the richer populations are the ones that are moving further distances and moving more. We also can look at how many people and the diversity of how many people each person is calling in their contacts. So again, anonymous data, but useful in terms of getting population level patterns. And what we tend to see is that the richer people are calling more, they have more contacts and are calling more people more often than the poorer populations. So it's a piece of information that we can start to use and map out. So here we can map out those distance to roads across the country. We can map out the brightness of the nighttime lights. We know that those populations further from in more rural areas tend to be the poorer ones. We can map out vegetation index, which those in the well-vegetated agricultural areas tend to be richer than the poorer vegetated areas. And we can use the mobile phone data to map out the percentage of calls that are made at night when calling rates are cheaper. We can map out how much people spend on topping up their credit on their mobile phones. And we can map out this radius of gyration, so how much do people tend to move. And again, just like the Afghanistan example, we can make use of that statistical models from that stack of data to estimate the wealth index across an entire country and fill in those gaps. And it works pretty well. In this case, we're explaining about 77% of the variation, which is not perfect, but pretty good. And so also important to measure out that uncertainty and where we're not doing so well. And so the aim here is to start to build up this kind of atlas of a country, the population density at small spatial scales, the proportion of the population that's under 5 years of age, and useful for targeting where those vaccinations need to be for children under 5, the proportion receiving the first dose of measles vaccine, the female literacy rate that we talked about right at the start, and the proportion living on less than $1.25 a day. So we can get to that stage of at least having estimates at these smaller spatial scales of that sustainable development goal indicator. So what is quite annoying, of course, is that it doesn't stay this way and people tend to move around. So, and in some places they move around a lot seasonally in the Sahel, in cities every day, and more people are moving around. This is quite something I put in, it's quite interesting. This is somebody who's surveyed 4 generations of his family to map out their entire life travel history. And so his great-grandfather lived in Kettering, didn't even make it over to the neighboring town of Corby in his lifetime. His grandfather had access to cars, trains, and so made it down to London. His father obviously was that generation that had access to international travel, made it all the way down to Corsica there. And then himself, he was a malariologist, so obviously a lot of travel to Africa, but patterns look largely like a lot of us do, except not perhaps the last 2 years because of COVID, but traveling the globe. And of course, flights is a major source of why we are all traveling much more. You see here, this is mapping out the each dot being a flight across the course of 24 hours. And we start to see here the massive amount of traffic over Europe as everybody wakes up. But what we can do, of course, is make use of this data source that's coming from aggregated and anonymized records from mobile phones. And we were interested in knowing, could these kinds of data be used to map populations and their dynamics? So we focused here on France, not a low-income country, but this meant we had access to aggregated data on the density of phone users and their calling patterns, and could compare it to census data to see, could we build a model to translate density of phone users into density of people? And it worked pretty well. And the value, of course, of these data is that they're collected every minute of every day. So we could map out changes in population density each day of the week. So we see here, we slow it down, I think we've got Monday, people at work, Tuesday, Wednesday, still at work, Thursday, Friday, and then Saturday out in the vineyards, Sunday, enjoying things, enjoying fine wines, I guess. And then the holiday period comes along, cities empty out and the coasts become really busy. And it's only since these kinds of data have become available that we've been able to see and measure these kinds of patterns. So that's interesting for France, but it's a country that has a lot of data already. What about a country like Namibia, particularly in the north? It's a poor area. This is a health facility in the north of the country. And often pinned to the wall is something like this that says our total population that we're serving is 1,928, but that's measured often from the last census 10 years ago and doesn't account for any kind of changes that may occur throughout the year that changes the demand on services. And of course, if you're measuring 100 cases of malaria and your population is 100,000, it's maybe not a big problem. It's quite a minor number of cases. But if actually your catchment population is 100, that's a massive outbreak because everybody's got malaria. So the value of knowing that denominator becomes pretty important. And so we translated the kind of methods from France to Namibia to look at the population density changes per square kilometer in this case. And we see December time, lots of people leaving the main city, it's blue, as they go to the northern areas where they're often working in the city and then have family in the north in the holiday time, and then back to the cities in January. And we see these fluctuations going on across the year that we've never really been able to measure before. And of course, that means we can, as work with the World Health Organization, we could actually see what's the likely demand on each of the health facilities based on those changes in population. It's also valuable data in the advent of a natural disaster. So in these kind of situations, there's often just chaos in terms of understanding how many people have moved where they're just being displaced to. These kinds of data offer a way to get a rapid assessment of where people have been displaced to, and those are often the people that are in need of aid. So after the Nepal earthquake in 2015, able to work with the local mobile phone operator to estimate where there were above normal population flows from Kathmandu, and these are then used to prioritize resources. A similar situation as a cyclone came through Bangladesh. How were people reacting? Where were they being displaced to be able to target those most affected? So this is a lot of interesting, cool maps. To try and get out of the ivory tower a bit to think about the real world use of some of these data sets. And the good news is we're starting to see these kinds of data actually being used. So whenever there is a hurricane coming through, whether it's an earthquake or a flood, we see that various UN agencies use these types of population data to assess how many people might be affected. So for instance, the Tonga earthquake that you've seen in the news recently. The COVID outbreak, these kinds of pandemic, these kinds of data sets are the basis now of some of the models that have been used to prompt the lockdowns that we've all experienced and were undertaken in the US as well. The World Malaria Report now assessing how many people are at risk of malaria, how many cases there are a year, make use of these kinds of geospatial approaches overlaid on these gridded population data sets to assess the number of cases. We're seeing UN agencies utilize these kinds of data as more fine spatial scales to prioritize resources. So this is looking at how many pregnancies there are a year for their State of the World's Midwifery reports. And of course, I mentioned the displacement monitoring. So these kinds of data have been used more and more in the post-disaster situation to understand where people have been displaced to. And in disease control, so malaria elimination settings, that where it becomes very important to understand how many cases are being imported to an area to design the most effective approaches. These kind of mobility data are being used. And the example I showed for Kabul and the population data. So this is me in probably the least gender balanced meeting I've been at, but that's former President Ghani, and these data were now then adopted and used within government to allocate resources to work out how much vaccine will be needed. Unfortunately, we've seen a change in government on a very serious situation since. In working out how many people there are in a country, Colombia did a national census, but couldn't reach certain areas of the country that were gang controlled. So here, these kind of approaches, using the geospatial data to fill the gaps, have been used to produce their national statistics. And then going right the way back to the DR Congo. We've been working recently across the country with field teams to collect new sample data and produce the first estimates, the first new data. Some of these people have not been counted since the 1984 census, but producing new estimates across the country. And these kinds of data are fed into then producing plans for polio eradication. So this is the vaccination tracking system for northern Nigeria. And in the north of the country, we saw these mapped data used. And it's only in the north really where we saw that there were no places really missed out on their states based on the population data, because the outdated census data that was used in the south caused a lot of problems, and estimated cost savings here of using these kind of updated population data of around 50 million of vaccines that would have been wasted. So if we go back to this goal 1, the good maps everywhere, the good maps of where and how many people there are everywhere, and the good maps of levels of poverty everywhere. I think there are examples now more and more of, in this case, this is focused on Nepal before the earthquake, very poor data. After a lot of data produced, unfortunately, it took an earthquake to do that for Nepal. But nowadays, there are more and more countries where this kind of automated mapping is being done. The population, this is now available at fine spatial scales. And the mobility patterns can be mapped out and then used in the kinds of models I showed previously to map out estimates of poverty at smaller spatial scales. So hopefully shown here that, just to summarize, that the maps are pretty powerful, but the national and regional maps that until I guess the last decade or so can hide significant inequalities, that there's a lot of people that are being left out when you summarize an entire country by one statistic. The traditional data sets that are collected from census and surveys are absolutely vital, but they can be outdated, incomplete, and unreliable in many low-income settings. And even in high income settings, we have a lot of change in between each census. So these kinds of approaches are being used to fill gaps. And these new data sets can help complement them, but they're not perfect. There's still a lot of bias, a lot of sensitivities, and a lot of uncertainties. And yeah, important thing for us is developing that capacity in these countries to undertake those kind of approaches themselves. That's the only way they're going to get adopted. So I've finished there, and many of the data sets, or most of them, we make openly available. So those that I've shown are on our website at worldpop.org. Yeah, I think we have about 44,000 data sets at the moment. It's a bit overwhelming, but they are all openly available for anyone who wants to explore.